Okay, today we're going to talk about the power law of exponents. We're talking about the power law. What we want to do is be able to have another rule that will simplify how we can combine exponents. Before we talked about that if you're multiplying the same base, that you're going to add exponents. Here, we're taking b to the second to the third power, which means that whatever's in parentheses here, just like we did before, has to be expanded. So we have b to the second 3 times. But then each of these also needs to be expanded. b times b, b times b, b times b. So if we go with our multiplication rule that we did before and we add all of our exponents, we end up with b to the 6th. What we can do is simplify that rule and say, just like we've done distributive property before, if we are separated by parentheses, you can multiply those two numbers together and not have to write out the entire thing in expanded form. So if we look at our practice here, think about what this means. If we have x to the third power, if we write in expanded form, it means x to the third, x to the third, x to the third. Each of those. If we expand each of the x to the thirds, we have 3 here, 3 here, 3 here, which gives us x to the 9th. So instead of writing all of that out, we can multiply 3 times 3 and get 9. We need to be careful that our exponent only applies to the number or letter that's right before it or in parentheses. So we're not going to multiply if we just had these. This isn't to a power. It has to have with our powers, our exponents have to just be separated by the parentheses side by side. So m to the second to the 5th power, that means I have 5 of these. And then if we split these up again, we're going to have 2, 4, 6, 8, 10. So we could take the shortcut and say that we have 2 times 5, which gives us m to the 10th. Now again, we can write these in numerical form or in exponential form, and I want you to write in both. So if we actually have a number, we can find what the numerical answer is. Here, we have to leave these answers because we don't know what x are and we don't know what m is. But here, we can multiply our exponents. 3 times 2 is 6. And think about it, if you can't remember if you're multiplying or adding, write it out. Then we can take your calculator, like we talked about before. This is your exponent key right here. So then you can say 5 to the 6th power gives you 15,625. Four to the 3rd power to the 5th, that means we're taking 4 to the 3rd 5 times, which we have 15 4s if we were to multiply that out. Now the reason we leave this in exponential form a lot is because this gets to be a really large number. If we have 4 to the 15th, that is a really big number. So we end up with 1073741,824. So what is that? A trillion? So it's a really big number. So that would be easier to leave it in exponential form because it's so large. Here's the negative again. We talked about this before. This negative has to stay in parentheses. So when we rewrite this, we have a negative 2 to the 12th power. And when you put this in your calculator, it has to have the negative. Parentheses, negative 2, exponent 12, which gives us 4,096. If you simply said this without the exponent, negative 12, negative 2 to the 12th power, that gives us a negative. It's not the same answer. We need to have it in parentheses. Same thing for negative 3. Negative 3 to the 15th power, because I multiplied 5 and 3. Parentheses, negative 3 to the 15th. This is the way you want it to look on your calculator, 3 to the 15th. So again, we get a large number. And this is our exponential. This is your numerical. So you can simplify that. Again, this notes a negative number must be in parentheses. Okay, if we raise a power to a power, anytime that you have two things in parentheses, understand that each of these has its own exponent. Simply use the distributive property like we've already done. That means 2b 3 times, 3 2's, 3 b's. Each of them has an exponent. This one we can simplify to 8, and so we get 8b to the third. This is just like our distributive property. 3 times 1, 3 times 1. It has to go to each thing in parentheses. We're only in this case we're talking about exponents. So this is our rule that's stated for this one. For any number a and b and any whole number n, which is just a number, this has to raise each factor to that number because each of these is understood 1. So we're multiplying it through. So if you look at this example, 3 plus 4 to the second, that is not equal to this because this whole thing is repeated. So this is wrong. And you can tell by the numbers that it's wrong. Here, 3 plus 4 to the second means we have 3 plus 4 2 times. If we simplify this part, we have 7 squared. Or this one, 7 times 7, and that's correct. So apply to each one, but be careful that you're not putting it into a parentheses when there's addition or subtraction. Okay, it's the entire thing. Don't get overwhelmed if you've got several things in parentheses. Take them one at a time. A squared, b to the third to the fifth. Means I have a squared to the fifth, b to the third to the fifth. So 5 times 2 is 10, 5 times 3 is 15. We don't know what a and b are, so we have to leave it. Here we have 3 to the first, and so if we multiply 2 times 1, we get 2. 2 times 4, we get 8. The number part can be simplified. X has to stay the way it is. So if you look at our practice here, some examples. This is going to be 4 to the third, a to the third. And 4 to the third gives us 64. You might want to work these out. Pause it and work these out before I write them. That way you can go back and check. Here's our negative 5. Has to stay in parentheses to the second power. 4 times 2 is 8. Think about how many of them that you have. So we have 25x to the 8th. You can ask yourself the question, how many x's do I have? Well, 7 3 times is 21. Y to the 5th 3 times is 15. This one we've got a combination. This has no exponent besides a 1 out here. These do. So let's take a middle step. We have a to the 7 times 2 is a to the 14th. This is b to the first, so 1 times 2 is 2. It's an a there. And then here we have a to the third, b to the fourth. So if we get rid of the parentheses, this is what we have. Then we're going to continue. How many a's do we have? We're not multiplying here. There is no more power to a power. It's simply multiplication. Go back to our rule of adding exponents. We get a to the 17th, b to the 6th. Same thing applies for division. It goes to each one. Keep your fraction bar. 2 goes to the top, x squared. 2 multiplies to the bottom exponent, 5 squared. And simplify it if you can. So you have x squared over 25. This is understood 1. On the top, we have 5 to the third. On the bottom, we have a to the 12th. And if you're still having a problem, you need to write them out. You get 125 for a to the 12th. On 13, apply to both. On the top, we have 3 to the second, a to the 8th. On the bottom we have b to the 6th. And think about if you write this out. This is what it means. 2 times. So on top we have 2 3s, which 3 times 3 is 9. We have 8 a's, and we have 6 b's. Take the extra minute to write it out if you're not getting these correct. I would put the ones, if there's not an exponent on each one, before you get started. That way you can tell that you're multiplying times 1 and you don't leave it off. So we have 3 5s on top, 10 x's, 5 4s on bottom, and 5 times 5, 25 y's. We can simplify. 3 to the 5th gives you 243, x to the 10th, and 4 to the 5th gives us 1024. And you can check and see if your fraction can be simplified, but normally if the number here, 3 over 4, cannot be simplified, then expand it out. It's not going to be able to be simplified. And we don't want decimals. We want to leave this in a fraction form if it can't be simplified. So use these examples and work on your practice for raising an exponent to a power.